Okay, let's do these. So here we're determining if these functions are even, odd, or neither. To check if a function's even or odd, we find f of negative x. If we get the original back, it's even. If we get the opposite back, it's odd. A lot of times you can check just by looking at all the powers. If all your powers are even, you got an even function. If they're all odd, you got an odd function. It's not going to help us here. He's not a polynomial. So we could just look here. X to the 6th, even. X to the 4th, even. X to the 0, even. So this will be an even function. So if we replace all the x's with a negative x in parentheses, an even power kills the negative. Even, or a negative to an even power is a positive. So we just get 3x to the 6th minus 5x to the 4th plus 2, which is the original. Everything stayed the same. So even. Running out of space here. This is an even function. G of x. Absolute value of x. Also an even function. We know that just by looking at the graph. Even means we have symmetry about the y-axis. But we could check it using the definition. Absolute value of a negative. Absolute value kills the negative. Negative disappears. I get the original function back. I've got an even function. Again, here we can check when we have a polynomial. Just check all the powers. That's an odd power. That's an odd power. That's an odd power. This is going to be an odd function. But we'll check it by the definition. By replacing all the x's with a negative x and seeing what happens to the negatives. Negative to an odd power keeps the negative. So this would be a negative x times a negative 2, or a positive 2x to the 5th. Negative to an odd power keeps the negative. Negative x times negative 7 becomes plus 7x. Notice that I ended up with exactly the opposite of the original. All the signs changed. That's the opposite of h of x, so that guy is odd. Here, I've got an odd power and an even power. If you have a mixture of powers, you're going to have neither. But we'll run it through the definition for completeness. Replace all the x's with a negative x in parentheses. So I've replaced all the x's with negative x's in parentheses. Even powers kill the negatives. Odd powers keep the negatives. I get negative for x to the 5th. Keep that negative. That negative dies. Plus 3x squared. Keep that negative. This is not the original. That 4 changed to a negative 4. It's not the opposite of the original. That 3 stayed the same. Neither. Even nor odd. Okay, here we're solving equations. If we're going to solve an equation, a quadratic equation, we need to be in standard form, so I need to get everything over to one side. Factor. And we get two solutions. Set each factor equal to 0. We get x equals 4 and 2. Here I'm going to solve this using the square root property. To do that, I got to get this perfect square isolated. So I get the 9 to the other side, and we'll get x minus 3 squared is 25. Take the square root of both sides. Don't forget the plus or minus. Over here, we get x minus 3 is plus or minus 5. So x is 3 plus or minus 5. 3 plus 5 is 8. 3 minus 5 is negative 2. Here, it may factor, may not. I'm just going to use quadratic formula. Where it came in the problem, or in the test, it's probably a quadratic formula problem anyway. So let's just use it. So x will be opposite of b plus or minus square root b squared. Negative 4 squared is positive 16. I already squared it. I don't need that square. Minus 4 times a times c all over twice a, so twice 3. Okay, so what do we get? We get 4 plus or minus. 3 times 4 is 12. Times 2 is 24. So I get 16 minus 24. That should be negative 8. Let's check that. 12 times 2 is 24. 16 minus 24 is negative 8 over 6. This can be simplified, simplifying that radical. Square root of 8 is 2 times square root of 2. We have a negative inside, so I'll get an I outside. And then if we want, we could split this up 4 over 6. It was fine like that. I could circle that. In a multiple choice test, though, that would have to be simplified. So you're always allowed to split numerators. I can reduce both of these fractions. We'll get 2/3 plus or minus I root 2 over 3, canceling the 2 and the 6. Okay, this guy. If we're going to use quadratic formula, we have to get everything on one side first. Okay, now let's use quadratic formula. X is the opposite of b, so negative 1, plus or minus square root b squared. 1 squared is 1, minus 4 times a times c. C is negative 10 over twice a. That's going to be negative 1 plus or minus square root. That's 41. That's a negative 40 times this negative, so positive 40 plus 1, 41 over 2. We're done. That won't simplify. Okay, finding vertex. H is opposite of b over twice a. So negative 60 over twice a would be negative 6. We get 10. We're halfway done. K is f of 10, which is going to be, this is kind of big. Plugging in a 10, we get 100 times 3. Hey, is this right? Let's check this. Opposite of b over twice a. 60 over 6 is 10. Yeah, so negative 300 plus 60 times 10, 600, plus 18, that is 300 plus 18, 318. So the vertex is the point 10, 318. Okay, page 2. Okay, we're just sketching a graph here. This is x squared, shifted 3 to the right, up 5, 2, 3, 1, 2, 3, 4, 5. We're done. Okay, here I am going to do this one in stages. Start with square root of x. Do the horizontal shift first. I'm going to go left 2. That's root x plus 2. Then I'm going to flip that over the y-axis. Do our horizontal reflection next. This whole thing flips over. Now Oh, this is cube root. I misread the question. So, easily fix that. Cube root. Okay, so it's going to flip over the y-axis. So this would be cube root of negative x plus 2. Now we're going to flip that vertically. It's going to flip over the x-axis. Go like this. So that's negative cube root negative x plus 2. Now finally, we're going to go down 4. That is f of x is negative cube root negative x plus 2 minus 4. Good way to check it. Check and make sure this center point satisfies the original equation. So if I plug in the point 2, I get a 0 here. Cube root of 0 is 0. Negative 0 is 0. Minus 4 is negative 4. Okay, next page. X-intercepts. Find x-intercepts. We set the function equal to 0. And solve. This factors, that looks like 6 and 4. So we get x is 6 and x is 4. So we get 2 x-intercepts. 6, 0, 4, 0. Solve by completing the square. We already know what answers we're going to get. We just solved it. We know we're going to get 4 and 6. But we're solving in a different method. So x squared minus 10x plus blank equals negative 24 plus blank. Half of 10 is 5. Squared is 25. That's what goes in the blanks. Left side factors. X minus, because of that minus. Square root of this guy, squared, equals negative 24 plus 25 is 1. Take square root of both sides. Don't forget the plus or minus. We get x minus 5 is plus or minus 1. X is 5 plus or minus 1. So x is 6 and 4. Now we're finding the vertex. H is opposite of B. B is negative 10. Opposite of that is 10. Over twice A. A is 1, so 2. 5. K is f of H. F of 5. 25 minus 50 plus 24. Pretty sure is negative 1. It's negative 25 plus 24, negative 1. So the vertex is the point 5, negative 1. Writing this guy in vertex form, we want A, x minus h squared plus k. A is right in front of me. I also now have h and k. You put the 1 there. You could leave that 1 out. It doesn't matter. X minus 5 squared. Don't forget that squared. Minus 1. Okay, now we're sketching a graph. I know the vertex is at 5, negative 1. I know my intercepts are at 4, 0, 6, 0. My y-intercept is at 0, 24. So, easy way to do that. Instead of counting up a bunch, just go, okay, there's 24. We're done. There's the sketch. And we're done with that page. Difference quotient problem. Okay, f of x plus h minus f of x all over h will equal. Let's write down f of x plus h. 3 x plus h squared plus 5x plus h minus 4 minus f of x in parentheses 3x squared plus 5x minus 4 all over h. Okay, x plus h squared is going to give me an x squared plus 2xh plus h squared. And distribute that 5. I'm going to distribute this minus. All over h. I'm going to distribute this 3. Then I'll do all my canceling. Get 3x squared, 6xh plus 3h squared. Just keep copying everything else down. Plus 4 all over h. Everything over here should cancel out. Dead, dead, dead. Cancels, cancels, cancels. Everything that's left better have an h in it. Everything that's left has an h in it. This guy, that guy, that guy. Factor an h out of the top. Cancel the h. Right, what's left over? 6x plus 3h plus 5. That's exactly what your solution should look like. Okay, playing the same game here. This one's going to be faster. F of x plus h minus f of x all over h equals. F of x plus h is 7x plus h plus 9 minus the original, 7x plus 9. Distribute the 7, distribute the minus. Nines cancel, the 7x's cancel. I get 7h over h. The h's cancel, I just get 7. Remember, we're finding average rate of change here. The average rate of change of a line is better known as the slope, which is what we got. Next page. Okay, first thing we want to do is isolate the radical. It's already been done, so I can square both sides. On the left side, I have to FOIL that out. X minus 5 times x minus 5. On the right, square root of junk squared is just junk. FOILing this out, I'll get x squared minus 5x minus another 5x, so minus 10x plus 25 equals x plus 1. That is a quadratic equation. I have to get that in standard form. I have to get everything on one side. So x squared minus 11x plus 24 equals 0. That factors. It better factor. We get 3 times 8 is 24. 3 plus 8 is 11. They're both negative. So we get 2 answers, x equals 3 and x equals 8. But we have to check those in the original. So plugging in 3. 3 minus 5 equals question mark. Square root of 4. 3 plus 1. Negative 2 equals root 4. No. X equals 3 is no good. We try 8. 8 minus 5 equals square root. 8 plus 1 is 9. Does 3 equal square root of 9? Yes, it does. X equals 8 is a good solution. Okay, this one. I hope I left enough room for this one. We have to isolate one of the radicals. I'm going to get this one by itself. Move that guy to the other side, and we'll get 2 plus root x minus 6. Then we can square both sides. On the left side, square root of junk squared is just junk. On the right side, square root, or that stuff I have to FOIL. That's what it means to square something. So when we FOIL that out, 2 times 2, we get a 4. The outers, we get a 2 times the radical. Inners, we get a 2 times the radical. That's a 4 times that radical. And then for the last, square root of junk times square root of junk is just square root of junk squared, which is just junk. It's just x minus 6. Okay, these x's cancel. On the, over here, I'm just left with 10. On the other side, I get a negative 2 plus 4 root x minus 6. Move that 2 over. Now, I saw a lot of people in class squaring both sides here, which is perfectly fine. There's nothing wrong with that. I'm going to make my life easier and divide that 4 out first. And get 3 equals root x minus 6. Now square both sides. 9 equals x minus 6. X equals 15. And we really have to check this back in the original, but I'm just going to write here, you check. It works. And we did the question in class. Okay, here we're building this vegetable garden. So I've got one side already built. I'm going to build 3 more sides. Let's call them L and W. Okay, these 3 have to add up to 30, so 30 must be L plus 2W, which means L is 30 minus 2W. I'm going to need that in a minute. I know because I've worked this problem 100 times. Area is length times width, but I have an expression for length. That's 30 minus 2W, length times width. So area, if I distribute, I get 30W minus 2W squared. Okay, we're looking for the vertex. Anytime you see maximize, we're looking for the vertex. The maximum area happens at some particular W value. So that's H is opposite of B over twice A. Twice A would be negative 4. That's 7.5 feet. And that's my width that maximizes the area. Then the length, I could just plug in here. Twice 7.5 is 15. 30 minus 15 is 15 feet. If I wanted to go a little further, I could find the maximum area just plugging this W in, or taking length times width. I could find the maximum area, but it didn't ask to. It just said find the dimensions, length and width. Okay, next page. Okay, sketching this graph. Two x plus 1 has a y-intercept at 1, 0, 1, slope of 2. So if I go over 1, up 2, it's supposed to be nice and dotted. I get that line. I want to start it, though, at negative 3. So I want to start here and go backwards. And I could find that y value, just plug in. Let's see, we get negative 6 plus 1, negative 5. And then I want x squared minus 4 for x is greater than or equal to negative 3. So x squared minus 4 looks like this. And that goes on forever. But I don't want the whole thing. I want to start it here at negative 3. I want this much of it right here. And then I could find that y value if I wanted. Negative 3 squared would be 9, minus 4 would be positive 5. So there's up at 5. And that's an open circle because no equal to, closed circle because of the equal to. Okay, this one. This one's got that really giant y value on this cubic. So I'm just going to draw a really rough sketch of it. So we want y equals 3. That's a horizontal line for less than negative 2. So I only want this with an open circle. Absolute value of x minus 4 plus 1 is absolute value scooted over 4, up 1. So I get something that looks roughly like this. That guy there. From negative 2 to 3. So that's negative 2 up to 3. Right there. Open circle at the 3. Close dot at the negative 2. And then this cubic, the whole thing would be scooted left 4, up 5, 3, 5, running here. Something that looks like this. But I want to start it here at 3. I only want this chunk of it. And I know it should be much higher than that, but I kind of had to play with my scale here. Then this y value would be whatever you get when you plug in 3 there. So we get these 3 separate pieces. Okay. This guy here, maximum height and the time. First thing we find is h. Let me write all. We're looking for the vertex. Opposite of b over twice a. Twice 16 is 32. It's a negative. So that's 2. That's my time. So the rock reaches the maximum height after 2 seconds. The maximum height we get from plugging this back in. So S of 2 will be, I'm going to do most of this in my head. 2 squared is 4, times 16 is 64, that's negative. 64 times 2 is 128, and then plus 80. So that's 64 plus 80, which is 144. This is my height. So the max height is 144 feet. Okay, when does the rock hit the ground? We set the function itself, the height, equal to 0. I'm going to divide through by a negative 16 because I wrote the problem so that that would happen. We get positive t squared minus 4t minus 5 equals 0. That factors. That's t minus 5. T plus 1 is 0. We get 2 answers. 5 seconds after Dave throws the rock, a second before he throws the rock, it hits the ground. That doesn't make any sense. The answer is 5 seconds. Negative time doesn't work in this context. Okay, solving quadratic inequalities. I'm going to graph y equals x squared minus 6x plus 8. I know he points up, And I know if I'm looking for x-intercepts, I'm just going to go ahead and jump to factoring. That's x minus 4, x minus 2. So the x-intercepts are at 2 and 4, and the graph points up. I'm looking to see where the graph is negative. That's this chunk here underneath the axis. So my answer is 2 to 4. Smallest, comma, largest. Okay. Want the answer in interval notation. Okay, same thing here. I'm going to graph this guy. I know you're tempted to move the 9 over and square root both sides, and there are ways to do it that way, but it's a lot more work. The easiest thing to do is graph y equals x minus 2 squared minus 9. So really quickly, we know that that's scooted right 2 down 9. And the graph's going to look something like this. We need to find these two x-intercepts. So I want to know where this equals 0. To find those x-intercepts. So we get x minus 2 squared equals 9. Take square root of both sides. Don't forget plus or minus. X minus 2 is plus or minus 3. So x is 2 plus or minus 3. So that's 5. 2 minus 3 is negative 1. So negative 1 and 5. So is our vertex, I want to make sure our vertex is halfway between their 3. Yeah, that looks good. So I want to know where is the graph greater than 0? That's these arms up here where I'm above the axis. All of that, all of that. I've got an equal to here, so I'm going to include my endpoints. So my solution, I have to write it here, negative infinity to negative 1 with a bracket, union, bracket, 5 to infinity. Quadratic formula, I mean, I guess I'll write it down, but you should know this. The reason we factor is to use the 0, actually write that, to use the 0 product property. Average rate of change will be g of 3 minus g of 1 over 3 minus 1. Biggest minus smallest. The difference in the y values over the difference in the axis. So let's see, I'll do these on the side. G of 3 would be 3 squared is 27, times 2 is 54, negative 54. Plus 15. Get my calculator out. 39. And that is negative. G of 1 will be 1 cubed is 1, so negative 2 plus 5 will be 3. Okay, so we get negative 39 plus 3 over 3 minus 1 is 2. So that's negative 36 over 2. So negative 18. And if we had units, we would write them. This has the units of slope. Units of y per x, miles per hour, feet per second. Y per x. But we don't have any units here. So we just circle it. Okay, that's it.